And now on this one, we are given the graph of a piecewise function. We're going to come up with the equations along the different intervals. I want you to notice that we have the points -4, -1, and -3, 2 along that first interval while it is increasing. And then it is constant along the next interval, going from -3, 2 to 1, 2. And then finally from 1, 2 to 3, -3, where we have it decreasing. That's a third interval where we have to figure out what the equation is. And we're just looking at line segments or rays here. So coming up with the equations. That'll take just a moment. Okay, so if we calculate the slope on the first interval, we've got 2 minus -1 over -3 minus -4. Subtracting a negative is the same as adding the opposite sign, so that's 2 plus 1, or 3, over -3 plus 4, that's 1. So we just have a slope of 3 for the first interval. On the second, since it's saying constant, horizontal, the slope is 0, and we're not going to have to do a lot of work to write the equation there. Along the third interval, -3 minus 2 over 3 minus 1 gives us a slope of -5/2 along the third interval. In just a moment, we'll continue that to come up with the equations along those three intervals. So how about those piecewise functions? Where's that noise coming from? I'm trying to mess around with my Zoom meeting here. Anyway, so remember, we're talking about a piecewise function. Each one of these pieces is going to have y isolated. So if I know on the first interval that the slope is 3, I'd be looking, although we'll eventually replace y with f of x, I'd be looking to write it in y equals mx plus b form, since we had a portion of a line. And we already know that the slope is 3. You could put in either point you like for x and y respectively. I'm going to plug in the -3, 2 here. And that's going to give us that b is equal to 11. So in between those 2 points, we're dealing with a portion of the line that has the equation y equals 3x plus 11. On the second interval, y didn't change, so y is equal to 2. And on the third interval, similarly, we have already worked out that the slope is -5/2. And 2 points on that third segment there are the 1, 2, and the 3, -3. Pick whichever you like, plug in for x and y respectively, and solve for b. I'm going to do something to get rid of the fraction for moments. Let's multiply both sides by 2. But then on the right-hand side, we will have to distribute. It doesn't just cancel the denominator 2 in that first term. It's also being multiplied to the b. All right. So let's work with the 1, 2. Four equals -5 plus 2b. So 2b equals 9. B is 9/2, i.e. 4.5. So I'm going to write this over on the board now. The equation we need to write, whatever we're going to name it, let's just say P of X, P for piecewise. We came up with 3x plus 11 on the first interval. That started, well, actually, let me look back at the graph here real quick. That one continues to the left, but it ended at -3. Whether I include that -3 on the first interval or not doesn't really matter, because it joins the next segment where things were horizontal. Let's just go ahead and say if x is less than -3, and then y was equal to 2, if we went from -3 up to +1, same issue. I can't include it on both because this is a function. Less of a concern because things joined up, but here I'll leave off the +1 for x on this as well, and then include it in the last interval from +1 to +3. That one got included. That's the last one. And we had -5/2 x plus 9/2. And before I stop the recording, I'm doing a quick double check to see if things make sense. First interval looks good. The second interval looks good. And the third interval. All right. So that's all I've got for now on piecewise functions. I hope that these videos are continuing to help. If so, press the like button, subscribe to the channel, and share with someone that you know that is working on the same and could use some help from watching these videos. And woo!